Hello everyone. Here we're going to review some fractions here. So let's start with simple basic numerical fractions. So when I have two fractions that I want to add and they do not have a common denominator, my first job will be to find a common denominator. So to add or subtract fractions we need common denominators. So this is a 15, this is a 5. What can I do to 5 to get a 15? Well, I could multiply by 3. So I'm going to do that here and here. Always in the numerator and in the denominator, because when you do that, it's like multiplying that by 3 over 3, which is just a 1. Multiplying by 1 never changes anything. This is why we are allowed to do that, because we're technically just multiplying by a 1, but it's a well-chosen 1. It's a 1 that's going to make us have a common denominator. Okay, so this one we don't have to do anything, so we're going to keep 11 over 15 plus 3 times 3 is 9, and over 15, right, 3 times 5. Now we have a numerator over a common denominator, so we can just write it as one denominator because it's common. And then 11 plus 9 is 20 over 15. And then we always need to simplify our fractions. And 20 over 15, both of those can be divided by 5, right? Let's write that down on the side here. I can divide by 5 on both of those, and so when I do that, I will get 20 divided by 5 is 4, and 15 divided by 5 is 3, so that will be my answer, 4 over 3. Okay, so now I'm looking at this one, and now I introduced some variables in it, right? But I'm still subtracting, and when I'm subtracting two fractions, I still need a common denominator, which I do not have. This is 9, 3 times 3. This is 5, just 5, right? 5 times 1. So what's my common denominator? Well, I'm going to have to multiply this denominator by 5, meaning I need to do that in the numerator as well. And this denominator is going to have to be multiplied by 9, meaning I need to do that in the numerator as well to get my 1, right? 9 over 9 is 1. Multiplying by 1 doesn't change my fraction. 5 over 5 is 1. Multiplying by 1 doesn't change my fraction. So why do I do it? Because now I have a 45 in this denominator and a 45 in this one, and because they're common, I can just write it as one single one. Alright, so 5 times 7 is 35. Don't forget your x there, right? Minus, and then 9 times 2 is 18, and don't forget your x there as well, right? And then 35x minus 18x will be equal to 17x over my common denominator of 45. 17 being a prime number, this doesn't simplify any further, therefore this will be my answer. Alright, next one. Now I have 3 fractions, and so I still need a common denominator because I'm adding or subtracting, right? So I still need a common denominator. So I'm going to ask myself, what exactly do I have? 9 is the same thing as 3 times 3. 12 is the same thing as 3 times 4, and then I have a 4 here. Okay, so what is it that I'm missing? I have 2 3's here, only 1 3 here, so I need another 3 here. Here I have 3 and 3, but I don't have a 4, so I need to multiply by 4. And then here I have the 4, but I'm missing the 9, right? The 3 times 3. I need 2 3's here, so I need to multiply this one by 9. Okay, I hope that's all. I hope that all makes sense, right? Because altogether, for a common denominator, 9 was 3 times 3. This is really 3 times 4. So I have 1 3, but I needed 2 at least to have a common denominator. So I need 1 more 3 here. Multiply that top and bottom. So I had that 4, but I was missing 3 times 3, so I need to multiply top and bottom by 9, right? So technically, my common denominator will then be 36, right? When I multiply 3 times 3 times 4, or 9 times 4, and then 12 times 3, or 4 times 9, all of that will be a common denominator of 36. Now let's simplify our numerators. 2 times 4 is 8, plus 5 times 3 will be 15, and don't forget your x there, and then minus, and then 3 times 9 is 27, and don't forget your x there. And then you're going to look if you have any like terms, and we sure do, right? We have a 15x minus 27x. That can be simplified. So we have 8. That would be negative 12x over my common denominator of 36. At this point, you have to ask yourself, do those three, because that will be, my numerator is as simplified as they can go now, but now you need to ask yourself, do those three have anything in common? Is there any factor I could take out? Well, 8 and 12 both have a factor of 4, so I'm going to factor out a 4. That will be 2 minus 3x. And then 36 has a factor of 4 as well, and that will be 4 times 9. Okay, 4 over 4, that's a 1, so that can be simplified, right? And so my final answer would just be 2 minus 3x over 9. Alright, now we're switching. We have a division now. So remember, when we're dividing, we're going to change the division to a multiplication, but we cannot just change that to the inverse operation without doing anything to that, right? So if I do the inverse operation here, I need to use my multiplicative inverse here as well. So this is the same thing as 6 over 1, right? And so you're going to keep the 1 over 9. You're going to change this division to the inverse operation, which is a multiplication, but because we use the inverse operation here, we're going to have to use the multiplicative inverse here. So flip it around, 1 over 6. And then just multiply numerators together. 1 times 1 is 1. And then 6 times 9 is 54. And that will be your answer for this one. Alright, here we are multiplying. So we don't have to change that, but now we need to look for any common factor so that we can simplify, right? So when I'm looking, you could do that different ways. You could go ahead and simplify here already, or you can multiply it through and through first and then simplify. It doesn't really matter, right? So let's look at it. If I would look at, well, 3 is a prime number, 5 is a prime number, nothing I can do with those. However, 8 is the same thing as 2 times 4, and 10 is the same thing as 2 times 5, so I can take out a 2, right? Because numerator has a 2, denominator has a 2, 2 over 2 is 1, so that can be simplified. Okay, so what's left over? 3x times 4x now, so 3 times 4 is 12. And now don't forget, we have an x times an x, right? So that's a multiplication, so now that's an x squared. Over, the 10 became just 2 times 5, and the 2 was cancelled, so we just have a 5 left over, so 5 times 5 is 25. And that will be your simplified answer. Now the other way you could have done that is multiply through first, so 3x times 8x would have given you 24x squared. And then 10 times 5 will give you 50, and then you would see that you have a common factor of 2, and so if you divide 24 by 2, you'll get 12, and divide 50 by 2, you'll get 25, and we would have the same answer, right? So either way you want to do it, it doesn't matter. Alright, multiplication here, so I'm going to look for common factor in my numerators and my denominators. I have an x square here and an x square here. X square over x square is 1, so that's gone. I have y and y squared. So on the side here, I want to recall that y over y squared is just going to be 1 over y, right? And so this y is gone, this square is gone, but I keep that y down here, right? And then 3 over 3 is 1, so those 3's are gone. Okay, let's see what's left over. 7, gone, gone, gone. So in the numerator, I just have a 7 left. Gone, gone. 1 y is left, right? The y squared, the square is gone, but we have 1 y left. So this will be my final answer for here. All right, number 7. This is an addition, so remember addition is we need a common denominator to be able to add. And to have a common denominator here, 5 being a prime number, I'm going to look at this number, that's a 40. How can I make 5 become 40? Well, if you would multiply by 8, multiply by 8. And so that will be, I have a negative in the front, so don't forget that negative there. Just put it there, and then 2 times 8 is 16 on your A, and then 40 will be my common denominator for both of those, so I'm going to go ahead and write that 40 there. And if I do that, let's move that negative to the 16 there, because only this one was negative, right? This one wasn't, so I want to make sure if I write it as one big fraction, I want to make sure the negative only goes with this numerator and not this one as well, right? Okay, and this one already had a 40, so it already had my common denominator, so I'll just keep the a, and it's a plus a. Okay, so like terms in the numerator, so negative 16a plus a will be negative 15a over my common denominator. And now I have to keep asking myself always, don't just stop when you have something done, right? Keep asking yourself all the time, can I simplify any further? Do my numerator and denominator have anything, any factor in common? And they sure do, right? This one can be divided by 5, which will give me a 3. This one can be divided by 5, which will give me an 8. So my final simplified answer will be negative 3a divided by 8. All right, I'm subtracting, and this is a negative. So when you see minus, minus, you should be confident that this here is just going to become a plus, so we need to get rid of that. And look, we already have a common denominator, so we're good there. So we have a negative x. That became plus, we said, 11x all over the common denominator we already had of 3. Now put your like terms together. Negative x plus 11 will give you 10x over 3. And then again, keep asking yourself, can I simplify any further? Do those two have any factor in common? And they do not. So that will be your final answer here. All right. A fraction divided by a fraction, we call those complex fractions, right? It's like a complex sentence in English when you have a sentence with 2 parts. This is a fraction with 2 fractions in there. Complex fractions. So when we have that, we're going to change that division bar to a multiplication. So remember how we did it here. Same thing. We're using the inverse operation of that division. And this is like a division, same thing. So we're going to use the inverse operation. So keep your first fraction the way it is. Change this division to a multiplication. But because we use the inverse operation, we need to use the multiplicative inverse. So flip that fraction around. Use the multiplicative inverse, and there it is. Now, when we multiply fractions, we just multiply straight through, numerator with numerator, denominator with denominator. So 5 times 5 is 25, and 2 times 3 is 6. And then again, keep asking yourself, can we simplify? Do those two have any factor in common? And they do not. Okay? All right, let's add some variable in that complex fraction now. So again, same thing, we have a fraction divided by a fraction. We're going to change this division to a multiplication, and we're going to use the multiplicative inverse of the denominator fraction. Okay, so this one stays 2x over 3. Division bar becomes a multiplication, and this one becomes 6 over 5x squared. Now, I want to see if I can cancel anything. An x over an x squared, the square will go, and the x is gone, right? I keep one of those x's though, right? Because we have x over x squared, that will be 1 over x. So no more x on the top, but we have 1 left down here. 2 is a prime number, so I can't do anything with that. But 6 is the same thing as 2 times 3, and down here I have a 3. So 3 divided by 3 is 1, so those are gone. And then 5 is a prime number, so nothing I can do with that. Okay, so multiply through. What do we have? 2 times 2, right? This 6 is gone, right? Because we rewrote it as 2 times 3. So 2 times 2 is 4 over, gone, 5 stayed, and 1x was left over. Remember we said 1x, right? So 5x is left in my denominator, and nothing simplifies any further, so we're done there. Okay. Alright, so now we're going to look at number 11. And number 11 looks really, really scary, right? We have a fraction, and then we have a complex fraction, because we have fractions in the denominator as well, but not only just one fraction, but we have a subtraction to perform here, right? So you could do that several ways. You can find the common denominator between those two first and write that as one single fraction, and then you can change the division to a multiplication and then flip that fraction you would have down here. Or you can ask yourself, let's see if I can find the highlighter here. I can say, what do all of those denominators have in common? What would be my least common multiple? And when I'm looking at that, I'm thinking I have a 2, a 4 and a 4. A 4 would be 2 times 2, and this would be 2 times 3. I said least common multiples. I didn't mean that. I meant the greatest one that's common, right? The greatest common factor. So 6 is 2 times 3. I have a 2 here, so the 2 will be included in 6. We're good to go. 4 is 2 times 2. I only have one 2 in here and only one 2 here, so I need another 2. And then I need a 3. So 4 times 3 equals 12. And on the side, this is my thinking bubble. Now I'm asking myself, can 12 be divided by all of those? 12 divided by 2 is 6. 12 divided by 6 is 2. 12 divided by 4 is 3. So it looks like 12 could be divided by all of those. So what I'm going to do is I'm going to multiply here and down here by 12. Now why is that allowed to do? Because I multiply the numerator by 12 and the denominator by 12. That's like multiplying by a 12 over 12, which is just a 1, right? Anything over itself is 1. And so multiplying by a 1 doesn't change the fraction, but it's going to help me to do it this way. So 1/2 times 12 is the same thing as 12 divided by 2. That's 6. And now here I have to distribute, right? So 5 over 6 multiplied by 12 will be the same thing as 12 divided by 6 is 2, so 2 times 5 is 10. Minus 12 times 11 over 4 Well, 12 divided by 4 is 3, so 3 times 11 is 33. And I'll just finish that. So I have 6 over, and then 10 minus 33 is negative 23. Now, we don't like negative in the denominator, so we can just move it kind of here to the front and do that, and that will be the same thing, and that's absolutely okay. All right. Complex fractions, operation with fractions in the numerator. So I'm going to do the same strategy I did here. I'm looking at all my denominators only, right? The denominators, let me highlight them. And I'm going to say, okay, what do all of those have? This is 2 times 2. Let me write that to the side. 2 times 2. This one is 7 times 2 times 2, right? And this one is just a 3. So I need 2 2's everywhere. I have them here, I have them here, I don't here. So this one has to be multiplied by 2 times 2, which is 4. I have a 7 here, which I don't have here and I don't have here, so I need to multiply by 7 everywhere. And then I have a 3 here that I don't have here and I don't have here, so I need to multiply by 3 everywhere. So really here it looks like oh, that looks ugly, doesn't it? Can I do that differently? Let's do that differently. Okay, let's not look at this here. That looks like kind of ugly. Okay, so I'm going to just demonstrate the other method of doing that. Right here I didn't show you the other method, but I told you there were 2 ways you could do that. I'm just going to show you the other method here, because it's going to be, I think, probably better. So I'm going to ignore that over 1/3 for now. I'm just going to leave it there and ignore it. And I'm just going to work with this up here. So ignore that. I need a common denominator to add those 2 fractions. Common denominator, I would have to multiply here by 7. So I need to do that up here as well. So 3 times 7 is 21. So I have 21 over 28, right? It's now my common denominator is 28. And then here I already have a 28, so I don't need to do anything to the 1, so just plus 1. Simplify that. 21 plus 1 is 22 over 28, divided by the 1/3 we didn't do anything with yet. And at this point I have a fraction divided by a fraction, so I'm going to keep my numerator fraction, change this division to a multiplication, and multiply by the multiplicative inverse of the bottom, so 3 over 1. This will give me 66, and 28 times 1 is just 28. And now I'm going to look at those and I'm going to see that they both have a factor of 2, so I can divide 66 by 2 is 33. 28 divided by 2 will be 14, and now they don't have anything in common left, so that will be my answer. That was probably better than the other way I was going to show you. You can do it either way, right? But the other one would have given us big, huge numbers, so might as well work with smaller numbers, it's easier. Okay, 11, 8, and 40. So I'm looking at all of that and I'm thinking, yeah, probably going to go with this method, right? Because doing this method, it's going to end up being big numbers as well. So let's ignore this fraction for now. So I'm going to just recopy it for now. And let's just focus on the denominator and let's see if we can subtract those. So I have a 40 here and an 8 here. Well, if I multiply 8 by 5, I will get a common denominator of 40. So I'm going to multiply this by 5 as well. Remember, that's just like multiplying by 1, right? 5 over 5. And so now 7 times 5 is 35 minus 11 over my common denominator of 40. Go ahead and simplify that. 35 minus 11 will be 24 over 40. I have a fraction divided by a fraction, so remember we're going to keep the numerator fraction, change that division to a multiplication, and then do the multiplicative inverse of the denominator fraction. At this point I probably could go ahead and simplify. I could have simplified maybe a little earlier, but at this point I sure could simplify. This one can be divided, so this is the same thing as 5 times 8, right? So I'm going to take an 8 out, 5 times 8. And this is the same thing as 3 times 8. So 8 and 8 is going to go, and I'm going to be left with 5 and 3. But look, we have a 3 up here and down here, so 3 and 3 are gone as well. So what's left over? 5 in the numerator, and then just my 11 in my denominator. That should be my answer. Okay? Alright, this is a multiplication here, so you could go ahead and multiply numerator with numerator. Remember, this is like having a 1, right, over 1, so 9 times 3 will be 27 over my denominator of 10 divided by 2 over 3. You now have a fraction divided by a fraction, so the numerator fraction, change your division to a multiplication and use the multiplicative inverse of the bottom fraction. And when I do this, I'm going to have 27 times 3. I'm looking to see if I have anything in common, and it doesn't look like numerator, denominator, nothing in common, right? So 27 times 3 will be 81. And then 10 times 2 is 20, and that will be my answer. Okay, when I multiply the same bases and I have exponents, see how I have an x and an x, the bases are the same, but the exponents are not. When you multiply the same bases, you add their exponent. So that's going to be x to the 2 over 3 plus 4 over 5. This is why this is in this section, because we're ending up adding fractions, right, in the as exponents. Okay, so that's going to be x to the what? I have a 3 and I have a 5. I need a common denominator, so this has to be multiplied by 5 and this one by 3. That will give me a common denominator of 3 times 5 is 15, 2 times 5 is 10, so 10 over a common denominator of 15 for both of those, plus 4 times 3 is 12. So that will be my base of x, and then 10 plus 12 is 22 over 15. And that will be your answer there. When we multiply the same bases, we said we add the exponent, right? But when we divide the same bases, we subtract the exponent. So this is going to be an x to the 1/2 minus the denominator exponent, right? Okay, so we need a common denominator. So I'm going to multiply this by 3 and this by 2. So 1 times 3, so for I need my x first, and then 1 times 3 is 3, minus 2 times 2 is 4, all over my common denominator of 6. Okay, 3 minus 4 is a negative 1 over 6. And because this exponent is negative, once I finish simplifying, we never leave a negative in an answer. So we're going to actually write it as 1 over x to the 1/6, right? Because a negative exponent just says your base has to be moved. You have to use the multiplicative inverse. So because this is in the numerator, I'm going to move it down in a denominator. Okay? Now, when we have a power to a power, we multiply the exponents. So we're going to multiply those two together. So 4/5 times 10. And when I'm looking at that, I'm thinking, okay, 5 and 10 can be simplified, right? 10 divided by 5 is 2. And so now my answer will be 4 times 2, which is 8. Okay, now I need a common denominator, but I have variables everywhere, right? This fraction already has an x in the denominator, so does this one. So x is already common to both of them, so I don't have to worry about the x. But this one has a 7 that this one doesn't, so I need to multiply top and bottom by 7. And so 7x will be my common denominator. And 7 times 3 is 21, plus 1. And 21 plus 1 is 22, over my common denominator of 7x. And there we go. All right. Okay. Subtracting two fractions, same thing as we've done. We need a common denominator, so look at your two denominators and decide what is missing or what could you do to make them become common. Both of them already have an x, so that's already common to both of them. What's not common is the 2 here. So I need to multiply this one by 2. And by doing that, I'm going to have a common denominator of 2x. So I'm going to write that as my one common denominator. And then 2 times 8 is 16. It was a minus between them, so minus. And then 2x minus 7. But now, be careful because this minus subtracts all of that, right? Meaning this negative is going to have to be distributed here. So that's going to be negative 2x, and that's going to become a plus 7. So negative 2x, and then minus minus becomes plus 7. Put your like terms together. 16 plus 7 will be 23, and then minus 2x divided by my common denominator of 2x. And we're going to leave that as such. Or do I want to leave that as such? Let me see what I want to do here. Yeah, I think I want to leave it as such. Okay. I mean, I probably could say this is the same thing as 23 over 2x minus 2x over 2x, right? I can split my denominator again between my two things in my numerator, but then that would go back to, that would just be 23 over 2x minus 1. But that's just as well here. But this would also be correct right there. Okay. All right, let's look at what we have here. This one has an x, this one has a 3, so there is nothing in common to both of those. So I'm going to multiply this one top and bottom by 3, and this one top and bottom by x. All right, negative 4 times 3 is negative 12, plus 5 times x, so 5x, over my common denominator of 3x. And I'm going to stop here, leave it like that. All right, what do we have here? I have an x minus 1 and an x minus 3. So what I need to do, I need to think about those as being one unit, right? One thing. So what we need to do is we need to multiply this one by that denominator So we're going to multiply by x minus 3. And this fraction has to be multiplied by x minus 1. So alright, that's going to give us a little bit of work to do here. So we have 1 times x minus 3 is going to be x minus 3. And then here I have to FOIL that, right? So x times x is x squared, so plus, it's a plus between them, right? So plus x squared. Negative x plus 2x will be plus x. And then 2 times negative 1 will be negative 2. And then over my common denominator of x minus 3, I'm going to leave this in factored form to see if eventually I can simplify anything, right? So I'm not going to FOIL those out. I'm going to go ahead and simplify my numerator, see if I can factor it again, and see if anything cancels with any of those two down here, okay? So leave your denominator in factored form, so x minus 3, x minus 1. Simplify up here, so I have my x squared is my highest exponent, so goes first. I have a 1x plus an x here, right? X plus x will be 2x. And then I have negative 3 minus 2 will be negative 5. At this point, you have to ask yourself, can I factor that any further? And can we factor this any further? And the answer will be no. So you can leave it like that. Or you can say, okay, since I cannot factor the numerator, nothing will cancel with the denominator, so you could FOIL out your denominator as well and say, okay, that will be an x squared minus x minus 3x will be negative 4x, and then negative 3 times negative 1 will be plus 3. So you could write it either way. Either way will be acceptable here, right? You can do either one of those. Okay, let's see. Where do I want to go? This one already has a common denominator. You see how we have an x plus 1 and an x plus 1? That's already common, so the only thing I have to worry about is distribute that negative into this one to make sure that my signs are good, and I can write that as one single fraction over my common denominator already. So it'll be 7 minus 3x minus 2. Right? Negative, positive is negative 2. Now put your like terms together. So 7 minus 2 will be 5 minus 3x over x plus 1. And that will be there. Okay, I skipped this one. But this one we would need a common denominator. So I would have to multiply this is the same thing as 1 over 1. And I would have to multiply by x squared minus 1, right? So I'm going to multiply that by x squared minus 1. My pen is... I'm losing it here, so let's try this one. And then I need to do the same in the numerator, x squared minus 1. And so 1 times x squared minus 1 is just going to be x squared minus 1. That's a plus, so plus x plus 5 over my common denominator of x squared minus 1. Now don't go ahead and cancel those, right? You can't do that because they are not tied by multiplication. We can only cancel if we are tied by multiplication. So simplify your numerator. So you're going to have an x squared, 1x here, and then negative 1 plus 5 is negative 4. And then you have to ask yourself, can you factor that? And the answer is no, so we can leave it as such. Oh, sorry, that should be a plus 4. I hope you probably already saw that, and you probably screamed at me through the camera, right? It's a plus, yes. It's plus 5 minus 1, so that's a plus 4. Okay. Let's see where I want to go. I think this video is already long enough. So let's just do one of those and then call it a day. Okay, let's maybe just pick one. Let's just do this one. So I'm looking at 2, 4, 4x. So I'm trying to look at all of those and decide what I could multiply by. And when I'm looking, I see a 4, 4, 2 goes into 4, and then I would need an x. So if I multiply, no, let's throw this one instead. If I multiply top and bottom by a 4 and an x. Now remember, why can I do that? Because multiplying by something over itself is like multiplying by 1, so we don't change the problem. But the reason we want to do that is because now when I'm going to distribute that inside here and here, I'm going to be able to cancel some of those fractions. So x over 2 multiplied by 4x. So on the side, you want to think about that as being x over 2 multiplied by 4x. You see how 4 over 2 will simplify to that, and so I'll have a 2x squared, right? Okay, so those two together will give me 2x squared. No more fraction. Multiply 4x times this one. See how the 4 will cancel here, and then I have x squared times x will give me an x cubed, so minus x cubed. And now the denominator. X over 4 multiplied by 4x. The 4 and the 4 will cancel to 1, and then x times x will become x squared. And then that's a minus we have between those, and then the x and this x will cancel, and I would have 1 times 4 left over. And this is what I would have. And then I would have to ask myself, can I simplify that any further? What can I take? Let's try. So could I take out an x squared out here? That will give me 2x minus 1, right? No, sorry, not minus 1. Mistake. 2x squared divided by x squared, the x squared will cancel, so I will have a 2 here. And a negative x cubed divided by x squared will be left with a minus x. All my pens are getting tired here, they don't want to work anymore. It's late already. And then this will be the same thing as x plus 2, x minus 2. So you're going to say, well, those two don't really cancel. No, but look, it's awfully close, because if I would factor out a negative 1 out of that, so if I take out a negative 1 out from both of those and bring it to the front here, I'll have a negative, and then my x squared that I already had. But by taking out a negative, that becomes negative 2, that will become positive x. So positive x, negative 2, I can rewrite them in this order. And now look, with my denominator, you see what happens? Boom, those two are gone, and so the answer will be negative x squared over x plus 2, and that will be your answer. Okay, we're going to call that a day. Review of fraction. I hope you feel a little bit more confident on what to do with fractions.